Hey everyone, and I was really happy because I just implemented a model context protocol for the very first time within my very first agentic AI. If you have watched my previous video where I have explained that my first agentic AI now have a capability to interact with the Postgres database, right? And now it has a lot of interaction with lot many tools, right? If I just showed you the current state of the code, right, these are the tools which we have, but all these tools are actually, so this agent is directly interacting with all these tools because we have all these functions here. And then we have this thing which is our brain of this agent, and then it gets okay, which tool to be executed, and then it start executing those tools, right? So it's kind of a monolithic architecture, so we have all the interaction from the external system with the agent in the same file, right? Which is not the right way of implementing production ready application. And that is where the model context protocol, which is given by or established by Anthropic, comes into the picture, right? And then when I just try to implement that, I really shocked. We just got a lot of advantage, which most of the these latest standard protocol and architecture provide, right? So now maintainability of code just got increased. We got a modularization, securities. We don't have to worry about the security because when you implement a MCP in a correct way, utilizing the MCP library of the Python version, this is the Python SDK for MCP. I'll just explain you code and the working application as well so that you will understand by yourself, right? So security will automatically come. You don't have to worry about the security, reusable components. So whatever the tools you are writing, which are running on a server, which, registered on the server, you can reuse them and anywhere, wherever you want. But if you have, the current way of implementation, you cannot use that without LLM, right? So these are some, fundamental problems which we have when I write this, first agentic AI. Right? So let's quickly just see how this, works in action. And then I'm going to give you the code walkthrough, how I have implemented MCP and how these advantages are being gained by this refactored agentic AI where I have implemented MCP. Right? So this is the application, if you ask anything. So, right, I'm just going to use this workflow so that I can precisely explain you each and every activity which this agentic AI is doing basically, right? So if you just see this task there, it involves two things. First, it has to do the calculation. So it has to perform arithmetic operation on two numeric numbers, 5 and 20. And whatever the result comes out, that has to be stored into this result.txt. So basically, it's a very simple task, but there are two activities to be performed. But let's see how agentic AI figures out all these things, how it understands, what has to happen, what tools needs to be executed, and how it has to communicate to the external system because now we have a MCP in place. So if I just click on this and now we can come back to this HTML. So what is happening? So the very first thing which our code is doing, it is trying to think what precisely the task is and how the task can be accomplished. So it is going to just analyze all these things and figure it out how this can be done. So it's try to understand, like, it analyze the entire task and it knows it cannot write the file until it has a result of 5 into 20. So it figures out what should be the very first step it has to do. So it just create this JSON file and then it moves this information to the next level where the MCP client comes into the picture for the first time. And it reads this JSON object, and then it decide which server needs to be triggered on and which function or which tool or which external system to be utilized by the server. And that is the information which client pass it on to the server, and then server execute that tool and give the response back to the client. And then, the client just, do the same activity again, try to understand what all task has completed and what is the next activity needs to be performed to just accomplish the task, right? So that is how it keeps checking. In the next round, once the server does the calculation, then it goes back to the control, goes back to the client, and again the agent start thinking, okay, now the first task is completed. What is the next task? Next task is I have to store this data into the file. So now it's again see that, okay, which tool to be executed is write to file. Whether this tool is in my internal registry. If it is not, then it is an external. So that is how it is just constructing the server. And I'm going to explain how this JSON is actually being constructed when I'm just going to give you the code walkthrough. And then again, client interact with the server, says that, okay, this is what you have to do. It will figure it out which servers to be hit now. And then it says that, okay, file system, then it goes there and it will find which do we have this tool which needs to be executed. Okay, write to file, and it will find, okay, these are the two parameter needs to give this function. Maybe I'm going to explain all these. Once this is done, it just give back to the client all the information. It actually gets stored. And then again, the agent thinks about it. Now both the task has been done and it has to just provide the final answer. And this is the JSON which is finally create. So that is how this task is going to be executed from the backend perspective. And you can see all these things which I just explained. The very first thing is try to figure it out. I mean, what task has to be done first. Then it tried to calculate, the calculator, basically the client comes into the picture, interact with the server, get the calculator done. Calculator actually just execute on a server side. So there is no interaction directly with the agent. Client is raising that request to the server and server is performing that. And now it is going to get the result back and it is going to be stored in the memory. And then for when it's try to do the next activities, try to just see the first activity has been done. Now it's again try to see which tools to be executed next. And this is how the complete task is being executed autonomously and we don't have to do anything, right? So now it has to generate this result.txt file. We can quickly check whether the result.txt is created. So we can see it's created and the response is 100 and that is what we are expecting. Now coming back to the code walkthrough, right? So this is just a beauty. Just think about it. Task looks very simple, but everything is happening by the agent. We are not telling for a human being because since it's a very simple task, that's the reason we feel that it's a very simple thing. But just think from the machine perspective, how it is dissecting these big tasks into the small pieces and keeping a track of everything. Though we have written the logic, but still, this is what the power of large language model is, which we are getting, right? So now you can see all the internal tool interaction in the same file. Agent is itself, interacting with everything. Now, if I just show you the new simple agent where I have implemented the MCP. Now, the very first thing comes into the mind, what library we need? We need a MCP library from, you can just search for the MCP PyPy. You will find this MCP, which recently just got released on July 18th, which is today, right? So now what you need to do next is, you have to import the client session because this is my agent and I just need a client. I'm not having any server component here. Just to give you the sense, but I'm going to explain all these things. Now here, if you just see, this is my server where my calculate function is actually running and this is the server and this is where I'm using this server. So from MCP library, I'm calling this server. Then we have a fast MCP. This is another wrapper which is just making implementation of MCP very easy. As you know, if you have used a fast API in Python, it's pretty much same kind of abstraction we are getting. So all the complexity is inside the fast MCP and we can just use a very simple code base to just write my client and the server by using the MCP, right? So now if you just see this, my agent, we have only few things, in my refactor simple agent. We have this class simple agent, my first constructor. This is my internal tool. We can just talk about that. We can remove that. That's not me. We need only two function now. We need just a thing, which is a brain of my agent. And this is the run where actual execution is happening. So if you just go back in my previous version, all the interaction is through the tools and everything. Agent is actually trying, this particular code is trying to do. But here, it's not doing that thing, right? So here we have a run, which actually interacts with client, right? So here, if you just see, we are using a xsync exit stack, which is a way through which what it can do is whatever the server is being executed by, this logic, it's automatically take care of shutting it down gracefully, right? Then we have a standard IO server parameter, like what all parameters to pass and what commands to be executed. And if you just see, this is what the MCP library is providing to us, right? And then we are, so this is just a stake and where we are just using a async complexity. I know this is a little bit of complicated thing, but you just keep in mind, like, I mean, here we are just creating a session and we are going to use that, right? So once the task is there, we are actually first calling our brain, which is our thinking, and then we just provide the task here with the task history, right? Whatever has been done so far, right? Here we can see. Right now, if you just see, the things are happening in a loop, right? So it's again coming into the thinking again and again. So first, it's just see the client session is active, right? So whatever the response you are getting here, right, the thought process, it just does some cleaning, and then it's try to understand what we have here. So if you just see, this thought process is actually being cleaned up, and then it is just converting it to the JSON. As I mentioned that, if you just remember the explanation, I know it's a bit complicated, but you will understand once you just keep tracking all these things, right? So this is the first JSON which LLM is going to create. How it is creating that? So this is where this think method comes into the picture. If you just see, this is what the prompt engineering comes into the picture. You have to understand how you have to design your prompt. So here, if you just see, if it has to utilize the external server, then this is the structure LLM should respond. If it is an internal tool, then this is the JSON structure. And if it is a final answer, then this is the JSON. So if you just see, if it is an external call, then there are three keys like server, tool names, and arguments. If there are a final answer, then there is this answer JSON object. And that is what we are verifying here, right? Once we have this response from our thinking function, which is actually utilizing large language model, it checks whether there is an answer or not. In the first activity, answer will not be there, but there would be a tool name, right, in action, right? So which is what we are verifying. Then we extract the tool name, and then we see whether it is having an action as a server or not. Because if it is having a server, it means that this agent has to interact with the external systems. And that is where the MCP client will come into the picture. And now you can see we are utilizing that here, right? So if you just see for this self client, you can see in the here we have this blank, and these are the servers to manage, and we can just search, I mean, where we are making this connection. So we can quickly search for the client session, and we can see here we are just making those connection, basically the session with the read stream and the write stream, and we just initialize that. So now the client session is active, and we can see all these things in a action here, right? So when we request it, we can quickly just, let me just explain things here. Right, when we start this, we can see what is happening. So we can see MCP client is active for the calculator, and that is what this code is suggesting. We have this, once we initialize it, we have this active. So client session is active. Now it is checking which tool to be executed, because based on which is decide which server name to be executed. And if you just see, this is where the server name is getting extracted. And if you just see how the server name is being extracted from this keyword, which is server, right? And that is what the action is giving us here in a server. So now we got the server name, we got the tool name, and now we know what execution has to happen. So now we are saying, okay, self.client, this is my session where I just enter the server name, and now I'm trying to execute the function, right? So this is my call tool, which is happening here, right? And I have to pass a tool name and the arguments. And arguments, again, we have the arguments in my JSON. These are the two things. So I'm saying expression means you have to just calculate this with the expression. If you understand the Python, then you will understand all these things, because now the Python understanding is actually needed at this point in time, right? So now it knows, okay, it has to execute the calculate function on one of the servers. So how the server is actually being recognized? So this is where this servers to manage comes into the picture. So we have Python based server, and which is tools and the calculator server. So now where we have this calculator, if you just see, this is what my tools folder is, and then we have a calculator server. Here, if you just see, I'm using an MCP server, right? And the fast MCP, right? And I'm just registering this calculator function over here, right? And then we have this function, and you just see we are using this decorator, which actually tells, okay, this is the function which needs to be registered for this calculator, right? So once you get this information, this function is going to be executed. And expression, we know this is the string which we are passing through that. Passing through the arguments, right? So we have that, right? So AST is, you can understand this AST is abstract syntax tree, which is a Python context, and it's parsing it, and then it's evaluating, and it's just executing that numerical, operations here. And once that data is done, then it is just returning back to the system. And now if we just come back here, we can quickly just come here and we can see this. Once, this result is, so we are using await because it's an async method. So we are just awaiting here, and then the results is actually getting stored here. And then we are passing into the tool. Same thing if there is no external interaction. If there is an internal interaction, then we don't need to go there. But right now, we should not be worried about that part. So, right, we have one internal tool just for the sake of purpose that, okay, are we making an external call or not? So we have this get time, right? So let me just quickly run the another get time thing. I mean, what is the current date and time? If I run this, let's see what happens, right? Okay, so now until, it's just executing that internal tool, but this is how, this logic is different, right? Same thing for the file system. Once the calculator is done, then again, it is going into the loop. That is what this is happening here. It's keep going into the loop until, the entire task is executed, right? So in the next round of thinking, it is going to just see whether, my task is completed or not. If it is not, because it just does the calculation, and then it will figure it out. Now the calculation is done, but now it has to save the data. To save the data, it has to read the file. It has to open the file and it has to save them. And that is where this file system server comes into the picture. So here, if you just see the difference, we have this file system, which is registered here, and we have two tools, right? And these are the decorator, which actually registered those two. And what are those two? Those are just a Python function, read file and write to file. And if I just show you the response for the second thinking output is, this is what the structure is: server, tool name, and the argument, right? Tool name is which function to be executed on a server side, right? And that is how it decides, okay, now it has to make the connection to the file system server, and on the file system server, there should be another function called write to file, and it has to execute that. So now we have two different servers, have a different function, and these functions can be interacting with your web, can be interacting with the database, and that's what I'm going to do in the next video as well. So basically, I will be just keep increasing my servers, with more tools, right? So definitely the next one is going to be access the webs and accessing the database as well. Right. So once this is done, I know that the code is a little bit complicated, but you need a Python understanding for that. So if you really need the access to the code, just reach out to me. This code is in a GitLab repo. So once you reach out to me, then I will invite you for the repo. All right. So that is how you can design your server. You can design your client, and through the client, you will have your agent interacting with the external system. Right. So let's quickly analyze, the another request where the internal information has to be done. So now we can quickly see what's the time. This is the current time, and we can quickly see it just thinking tool name. There is no argument. So basically, this is the different JSON. This JSON will only be responded when there is an internal tool, right? If you just see the structure, right? If it is an external server, then this is how the JSON would look like. If it is an internal tool, then you only have a tool name, not the server key. And that is what we are seeing here. So it is not only able to figure it out whether it has to interact with the external system, it can interact with the internal tools, because in real time, there could be some small thing which you would like to do it internally rather than going for the client to server, which is definitely going to have some kind of latency introduced to your solution. Right. So now what kind of advantage we are going to get, right? So as you know, once all these tasks are active, tasks are done, then it will again start thinking, and so again this thinking function will come into the picture, and then it will realize there is no tools to be required, and it will see the JSON response, and it will find that. Then it will just generate, okay, there is no task, then it will just create the answer, and it will give you this, right? And then that is where this logic comes into the picture. It will check what JSON response is getting, and once it finds this answer as a key, then it is just breaking this loop and coming out from that, and then it's just responding back with the final answer, right? And if you just see, there are a lot of complicated concepts which I have utilized from the async model, so you really need to understand all the. I know async and is something which is a little bit complicated to understand at the first sight, but definitely it's not something. If you will spend some time, you will understand all these things very thoroughly, right? So this is from the code walkthrough perspective. Now these are some high level advantage which we gonna get, right? Difficult to upgrade. We know that if we have a monolithic and if we want to upgrade it, we have to take care of a lot of stuff, right? But since now we have, modularized code basically, right? Each tool are on a different server. So if we want to just upgrade one simple server, it's very easy. We don't have to bring down the entire application or solution. We can just directly go to the server, make the changes and make that server up and running. So the code is completely decoupled. Now, if you just see and it's compared with this previous giant monolithic code base, now you can simply see that my agent is very clean, right? It's very, very simple. All we are doing is just trying to interact with the client, and the rest of the interaction from the external system is being taken care by my client. And then we have a different servers for the different interaction. And if we want to include more servers, we can easily add those server, or if we want more tools on this server to rely on, so we can add some more tool as well to these servers, right? So it's completely depend upon your use case, whether you need a multiple servers or on one particular server you can have all your tools. It's just a logical grouping of your tools depending upon what kind of activity needs to be performed, right? Right. So if you just understood now, if we have a decoupling and all those kind of stuff, and the agent is not directly interacting with the external system, obviously the security is just coming automatically when you just try to implement the MCP in a correct way. Your code is maintainable, it's modular, and if you want to scale it, you can easily scale as well, right? So now, even if you want to change, your server code, if you want to write in a different programming language, that also you can do, because your client is not worried about what kind of language you are using. It's only just interacting with the server. And once it's interact with the server, then it's a server responsibility to understand how to execute that code. So you can just write, different tools in a different programming language as well. It's kind of giving you the sense of a microservice module as well. So reusability is there. If you want to use this class, you can use anywhere as well, not only in this particular solution, right? So all these advantages, as I mentioned, once you implement it, you will automatically get to know what kind of advantages we are getting, right? So if you just see, using the model context protocol is not a different way to organize code. It's a professional architectural design that build more secure, scalable, and future-proof system. And we have already understood that how we are achieving security, scalability, and the future-proof system. It transform tools from a simple internal function into the independent, robust, and reusable microservice. And that's completely true, right? And these are some attributes, some advantages which we are getting: security, scalability, maintainability, flexibility, and the robustness in our solution. Right. Now, the another thing, if you are wondering, I have used this standard IO, so these are the three transport. If you just see, you can just understand how these three different, transport works. So I just use this standard IO, which actually good for local development. So this agent start the tool server as a local sub process, which makes, just communicating to the server is far easier, right? Right. So local development is good, but it is having some limitation, like cannot be scaled independently. The tools runs from the same user permission and all those kind of stuff. So that is where the streamable HTTP come into the picture, right? So if we know that if we are using a HTTP based, connection from client to server, then definitely all those limitations which we have, this standard IO, we will overcome with that, right? So probably in the next video, I will add some more tools like interaction with the web, interaction with the database. And once we are done with that, then probably we will migrate our standard IO based, interaction from client to server. We will use the streamable HTTP. Right, so which is more closer to how to make your production ready system. Most setup required, you need to manage network ports, so those kind of things which we will handle once we just try to migrate to the streamable HTTP. The next thing is the servers and events, which is actually moving to make your agentic AI, grabbing information in our real time, right? So this is what this real time notification, use case is. If a tool needs to send progress and updates to the unsolicited alert back to the agent, at that point of time, you have to utilize. So I don't know whether we need to just go for that complicated one to start with, but in the next video, definitely I will just try to add a new tool, one for accessing the web and the another one is for accessing the database basically. And then we will try to migrate to the streamable HTTP and see what's the difference we get when we move from standard IO to the streamable HTTP. Right. So this is what, I want to cover in this video. And that's it from my side. And if you have any feedback or suggestion, please feel free to put that into the comment section. And if you really like this video, give a thumbs up. And if you haven't subscribed for my channel, please subscribe for my channel as well. And since I know this is a very complicated topic, and if you feel that there are some mistake I made during the video, just highlight that, and I will be more than happy to hear where I just made a mistake during the explanation. But I would urge with all of you that try to implement this MCP architecture by yourself, because that is the best satisfaction you get when you try to implement some complicated concept by yourself, because things becomes very clear in your brain. You can easily visualize how the things are happening, how the flow actually just going from one end to the another to fulfill any kind of transaction or any kind of task which this agentic AI is supposed to do. Right. So that's it from my side. Thanks for watching this. And as always, stay healthy, keep learning new things.